Good afternoon, friends. Today we'll understand the method of drawing the velocity diagram for the given mechanism. Consider that there is one mechanism given of the slider crank which has the crank AB and the connecting rod BC and the fixed link A, which is held at point A, as well as it is also having one slider which can slide in this horizontal direction. We have seen in the earlier lecture that the link AB, since it is having the rotating pair with respect to point A, the point B can only rotate with respect to point A. In this case, the point B will have the velocity tangential to this curve or perpendicular to the link AB. Since it's given that the link AB is rotating in the clockwise direction with 180 rpm, that means that velocity of B with respect to A will also be in this direction. Now, plotting the velocity of AB, we'll just consider the point A over here and we'll draw a parallel line or the perpendicular line to AB such that its magnitude of the AB is given by omega AB into AB, this distance, which is equal to 180 rpm. So convert it into radian per second, which is 2 pi by 60, into the length of AB is given to be 350 mm, which can be written as 0.35 meters. So just calculate 180 into 2 pi into 0.35 divided by 60 is equal to 6.59, right? This is in meters per second. This is the velocity of AB, which is nothing but AB, right? Now let us consider a suitable scale, that is 1 meter per second is equal to 1 centimeter of the drawing. Hence, this AB can be marked along the perpendicular direction to the AB with 6.59 centimeters. So this is your AB. This direction will represent velocity of B with respect to A. Okay, sorry, this is your BA. Excuse me. Now, there is one more link BC. For the link BC, we do not know the angular velocity BC. Hence, we cannot exactly pinpoint length BC. What do we know for this link BC is that the velocity of point C with respect to B will always be in this direction, which is perpendicular to the link BC. Since this link BC is having the rotating pair at point B and this is a rigid body, the point C can only have a perpendicular velocity along this direction or this direction. Now it is from the point B, therefore from the point B we will draw one perpendicular line. This line is perpendicular to link BC, right? This AB is perpendicular to link AB, right? This is very important. Now we have seen that we have already discussed that the point C is having the sliding velocity, which is either in this direction or this direction with respect to the fixed link A, right? A can be written over here as well. So from the point A, the link C is having the horizontal velocity which can be in this direction or in that direction. It is just a horizontal direction. Now this is the locus of C. This again is the locus of C. Hence the point of intersection has to be the point where the point C exists. So here you got a triangle, a very nice triangle, which is represented by this A, B and C, right? Now this direction, this link AC represents velocity of C with respect to A. The direction is a horizontal and the magnitude is calculated by the length of AC. Length of AC is equal to velocity of AC, which is equal to some dimensions which can be calculated directly from here. So let us just assume that this is something near 8 centimeters. So here, which is equal to 8 meters per second. Similarly, velocity of C with respect to B is given by the length BC represents velocity of C with respect to B, which is given by, just say that this is some 4 centimeters, hence which is equal to 4 centimeters or 4 meters per second, right? So in this way we can calculate the velocities of different points and we can draw the velocity diagram. Note that if we interchange the direction of BC from this direction to, this is B and this is C, from downward direction, this will represent velocity of point B with respect to C, whereas this will represent velocity of C with respect to B. There is no change in the magnitude of velocity of B with respect to C or velocity of C with respect to B, but the direction of velocity of B with respect to C will be in the opposite direction to the velocity of C with respect to B. In the earlier video we have explained that whenever we are drawing the direction, we represents the final point, which is the point of observation from the frame of reference, which is the initial point. So the starting point over here is C, whereas the final point is B. That means you are observing the object B from the point C. That means this is the velocity of body B with respect to body C, right? Now one important point is there: velocity of intermediate point. Velocity of intermediate point. Let us assume that onto this link BC we have somewhere over here point E, such that we also have to calculate the velocity of point E with respect to fixed frame, that is A. This is absolute velocity of E, absolute velocity. So in order to do that, we can use the relation which is length of BE divided by length of BC. See, BE is here and BC is here, that is on the same line, is equal to length of the velocity triangle, which is B, and here somewhere will be the point E, divided by BC. This is BC. BE upon BC. So how to locate this point E? We do not know the length of BE, so BE is equal to BE upon BC into small bc. By that it will be easy to locate the point E, since we get to know the length of BE, and if we join the point E from the A, this will be velocity of E with respect to A. This will represent velocity of E with respect to B, and this will represent velocity of C with respect to E. Right? This is your point. So velocity of E with respect to A is equal to length of AE, which is not length of AE but length of AE, which may be equal to something like 7 meters per second.